Welcome to our next complex numbers video, our fifth video on actual discussing complex numbers. Now, we're going to talk in this video about complex roots for cubics. In the last video, we talked about quadratics, and now we're stepping up to cubics. There are three scenarios that could happen when we solve a cubic equation. We could find that there are three real unique solutions. Scenario 2 is where we have one real and the other two are also real but repeated solutions. And scenario 3 is the one we're going to explore in this video, where we have one real solution and the other two are complex solutions. All right, here's our example for the video. Find the solutions to the cubic equation. Z cubed plus 3z squared minus 3z plus 4 equal to 0. Now again, we could use x's, but because we know that there are complex roots, we replace x's with z's. Okay, so this is scenario 3, where we have one real and two other complex solutions. All right, well, let's start off with the plus 4 and go all the way back to the factor and remainder theorem and start plugging in factors of 4 to find one of the real solutions. So let's plug in 1 and negative 1 and 2 and negative 2 and 4 and negative 4. Hooray, we finally found a value of 0, which tells us because we've substituted in negative 4 into the equation, we know that one of the factors is z plus 4. So we've found the first solution, and that's the real solution. The solution is when x is equal to negative 4. Right, well, now we've got the other part of the cubic to go. And we're going to have to go back to a long division video, a few videos back, and we're going to divide x cubed plus 3x squared minus 3x plus 4 divided into the factor we do know, which is x plus 4. Notice I'm changing from x's to z's, don't get too confused with that. And we come to the expression of x squared minus 1x plus 1. So that must be this part here. And again, I'm replacing it back with z's. So we've got z squared minus 1z plus 1. All right. Well, if we tried to take this quadratic now, this part's a quadratic, and the third bracket makes it the cubic. If we try to solve this quadratic, so put in a is 1, b is negative 1, and c is 1 into our calculator to solve, you'll notice it comes up with no real roots. That's because it can't be solved because they're complex roots. So we're going to have to step back using the quadratic formula once more. Notice I've replaced x with z once more, and we're going to replace the a's, b's, and c's. A's with 1, b's with negative 1, and c's with 1. And we're going to simplify it down to z is equal to 1 plus or minus the square root of negative 3, all divided by 2. Now, again, we can replace the negative 3 with 3 times negative 1 and replace the negative 1 with I squared, and then we can square root it to get our solution. Now, just be very careful here. This is the square root of 3 times by I. The I is not inside the square root. Okay. Now I'm going to simplify to my two solutions. My first solution is 1 plus the square root of 3 times I divided by 2. And the second solution is 1 minus the square root of 3 times by I, all divided by 2. So I'll grab my calculator. I can work out the real bit by going 1 divide 2 and the imaginary bit by going square root of 3 divide 2. Now I'm ready to write down my three solutions. So here we go. My first solution is my real solution, which is negative 4. My second solution comes from this solution, which I'm going to write in decimal form, 0.5 plus 0.8660i. And my third solution comes from this solution, which I'm again writing in decimal form, 0.5 minus 0.8660i. So those are my three solutions. One is real and two are complex solutions. Keep in mind, some people really prefer to write solutions left in surd notation. You can do that or decimal, it doesn't matter. Right, thanks for watching.